Two cubic polynomials are defined by f of x equals this and g of x equals that, where a and b are constants. Given that f and g have a common factor of x minus 2, show that a equals minus 4 and find the value of b. Using these values of a and b, factorize f of x fully. Hence show that f of x and g of x have two common factors. So that's the question then. I've got it summarized here. So we're told that x minus 2 is a factor of both f and g. So let's use that part of the question then. Here we know that 0 is equal to f of 2 because x minus 2 is a factor. So put 2 in here then. 2 cubed is 8. Put 2 in here, we get 2 lots of a minus 3 plus the 2b. So what does that tell us? It tells us that 2a there plus 2b, and then we've got 8 minus 6 is 2. I'm going to move that over to be the zeros to be minus 2. So that tells us then divide by 2 all the way through. A plus b equals minus 1, and label this as equation 1. Also then, g of x is a factor, isn't it? So g of x minus 2 is a factor of g. So 0 is equal to g of 2 also then. 2 cubed is 8, 3 8s are 24. 2 squared is 4. 5a times 2 is 10a. And then 4b. So that tells us now then that 10a plus 4b, I'm just going to write it here, must equal, well we've got 28 and we're going to move that over to be minus 28. There's a 2 common, so divide by 2 all the way through. 5a plus 2b equals minus 14. This is number 2. Okay, so because we've got a 2b here, what I'm going to do is I'm going to, rather than label this, I'm just going to label that one there as 1. And now we can just do the difference. If we this take that, then this is a bigger number of a than that, isn't it? So we'll do 2 take 1. We'll do it that way around, so we get a positive a quantity. 2 minus 1 gives 5a take 2a is 3a. 2b take 2b is none. No b's, that's why we're doing it. Minus 14, take away minus 2 is plus 2. Minus 14 plus 2 is minus 12. So move the 3 down. 12 over 3 is 4, so a equals minus 4. And then b, well, we can get it from here. So b is equal to, move the a over, minus a, which is minus 4. Minus the 1 that's already there, which is 3. B is 3. So we found A and B. And I think that's what the question asked for. Show that A equals minus 4 and find B. Factorize f of x fully. Okay, this is f of x here then. Let's just grab it and we'll deal with that and factorize this fully. So let's have a look at this then. So I've got it here from the question. Okay, and this is part 2, I take it. Yeah. So factorize f of x fully. So f of x is equal to x cubed. A is minus 4, so we've got minus 7 here. And b is 3, so 2 3s are 6. Here, x cubed minus 7x plus 6 is equal to, now x minus 2 is a factor, and then it's going to be a quadratic, isn't it, that we don't know. I'm going to call them, we've used a and b, so I'm going to use a and b again now. Doesn't do no harm. Plus bx plus c in here, in this part of the problem. Okay, so let's equate x cubed then. One of these is equal to ax cubed, so that's just a equals 1. in this part of the problem. And we'll equate constants next, of course. We get 6 is equal to the minus 2c. So that tells us what c is. Move the minus 2 down. 6 over minus 2 is minus 3. Now the next thing to do is equate x squareds, isn't it? Because there's none on this side, so it'll probably be easiest to do that. No x squareds on this side must equal. Well, there's a bx squareds, and there's a minus 2a's. So b is equal to 2a, 2 lots of a, 2 ones are 2, so b is 2. So f of x equals then? So f of x is equal to, well, it was x minus 2, wasn't it? And then we've got a, which is x squared, plus b, which is 2, x's, plus c, which is minus 3, which equals x minus 2. Factorise this then, x and an x. It's got to be 3 ones if it works, and it needs to be a plus 3 and a minus 1. So there's f of x factorised completely then. Now let's go back to the question. Hence show that g of x have 2 common factors. Okay, so the g of x, then let's just grab that. Okay, and we'll pull that down now and work with this. Now we need to show that one of the other factors of f is also a factor of g, so it's only a matter of putting in the values here. So here then, g of x is equal to 3x cubed plus x squared. Now 5a from before, a was minus 4, so that's minus 20x. And b, let's just go back up and look at the original problem, 3. So 4 3s are 12. Now let's put in a value. Let's try either 1 or 3 or minus 3. I'm tempted to try 1's probably not going to work because it's not big enough. So let's try minus 3 is equal to minus 3 cubed is minus 27 times 3 is minus 81 plus 9 minus 3 squared. Minus 20 times minus 3 is plus 60, and then plus the 12. 72, 81, take 81 equals 0. So x minus 3 then. So x plus 3. So x plus 3 is also a factor of g. Of both g and f. And I think that's what the question, let's just double check, that's what the question asked for. Yeah, factorise fx fully, hence show that f and g have 2 common factors, which they do. The only other thing to say is that g of 1 here doesn't equal 0. So they just have 2 common factors, because it's easy to see that with g. Here if you put 1 in, you'll get a non-zero amount. Because that's 4, 16 minus 20 is minus 4. So you could note that if you wished.